Coming up next on the IP Talk stage, our keynote presenter, John Heinlein from ARM, presenting Realizing the Next Wave of Smart Devices.
Into the air, and if you can't see it, there's the person on the other side. And it's called the Sky Coaster. It's kind of like a roller coaster in the sky. It's an amazing experience, highly recommended. But as I was walking stiff after this, it occurred to me that this is actually not so different than our experiences in advanced design today. Because today, advanced design shouldn't be a leap of faith. And when you're doing a tape out, and a tape out costs around $6 million, you need to be darn sure that that tape out is going to work the first time. And in today's competitive environment, when time to market is everything, and when a chip design costs upwards to $100 million in total hardware design costs, you need to be very confident that what we're delivering is going to achieve the results in a timely way. So today, and here background music, here are the kind of challenges we see. You know, if you miss your market window, it's going to significantly impact your profitability on these designs. Power management and hitting your power budget is extremely important. Likewise, achieving a competitive design cost so that your net result is competitive in the marketplace is crucial, and also time to market is critical. So to describe these topics, I'm going to break it into two parts. First, I'm going to talk about the trends in the next wave of smart mobile devices. I'm going to tell you a little bit about the market and what we see coming up in the market from these many different important market segments. Then the second part I'll talk about is how do we achieve these designs confidently in a time-to-market way, in silicon, and at the right specs. Okay? So let's begin first with the mobile devices. And I'm going to begin first with the general mantra that ARM talks about, which is that we believe the world is increasingly mobile and connected. And there's a multitude of devices that enable our connected world. Of course, it's very easy to talk about smartphones. Let me give you an anecdote about smartphones. In 2010, at Christmas time, IBM did a study, and they found that around 8% of commerce-related transactions at Christmas time emerged from a mobile device. 2011, that number was 18%. So significantly increased usage of mobile devices, not just for everyday things, but also for e-commerce, and that's really important. But we're also seeing that it's not just about smartphones. Of course, you're now seeing an expansion into the tablet space, where tablets are becoming a market on their own and becoming a pretty substantial part of the market. You're also seeing devices like that's convertible tablet over here on the side, which bridges laptop and tablet functionality and gives you the opportunity to have a combination experience that gives you laptop-like capabilities. Likewise, smart TVs. Smart TVs these days have a lot of the capabilities of a kind of a giant smartphone. They have apps, internet connectivity, and high-resolution screens. So in general, we see important trends in mobile devices where mobile devices are becoming more and more your primary platform. You know, things like, for example, media. All of your mobile, all of your music and your videos are on your mobile device, and you carry it around with you. Things like mobile e-commerce. I know I do a ton of e-commerce directly from my phone, and more that's the trend. And so one of the things ARM is doing is working to enable better security for e-commerce. Things like location awareness and augmented reality. If you've never played with one of these applications where you hold your phone up and it shows you what you're seeing in front of you, it says there's a great noodle shop there and there's a great place to get coffee, they're really fantastic. And that's going to become more and more the trend with location awareness. And likewise, high performance networking and LTE networking means that you can have great connections to the cloud at all times, and that's really important. So what I want to go through is a couple of different segments and talk about some of the trends we see across different segments. First, with mobile. Now, this is going from now 2012 to around 4 years out, 2016. What are some of the things we're seeing? Well, first is customers expect great user experiences across any form factor, whether that's in a smartphone, a tablet, or a TV. We're expecting great responsiveness. And so what ARM is doing is working with something we call right-sized computing, and I'll talk more about that later, where we give different capabilities and different performance points depending on the application space so you can achieve great user responsiveness and a great experience. We're seeing screen sizes are going up. We're now seeing tablets and even phones that have very high-res screens, and even 2K, which is sort of the next generation of high def on TV platforms as well. Of course, high-performance broadband LTE networking. Another thing that's interesting is the drive for this connectivity means that there's an increased demand for servers as well. So every 600 smartphones drives the need for a server. So one of the things ARM is also doing is working to get engaged with cloud computing as well. And it's something we've begun to talk about more and more. Where in the past, the computing platform used to be just a vehicle to get things done. Now more and more, the computing platform and the cloud is the value you're adding to the customer. And so what ARM is doing is to realize that just in the same way that density and power and battery life are important in mobile devices, density and power efficiency and cost are important in server devices as well. So rather than using a one-size-fits-all type of processor for your server applications, what ARM and ARM partners are doing is working to deliver optimized SoC kinds of implementations to deliver server platforms that are more customized, more energy efficient, and more dense. Because if you ever seen one of these server farms, it's a giant building that basically has power and internet comes in the one side and heat comes out the other. And it's all about how much data can you take in and out and how much processing can you deliver for a given heat budget. So if we can do more with energy efficiency, if we can do more with low power and energy efficiency, it's much more powerful. And we expect to see a 20-fold increase in internet traffic over the next 4-year period. If you continue on into the Internet of Things, we talk about the Internet of Things as connectivity of things that you don't classically think of as being connected, and also putting intelligence in things that you don't think of as being connected. Things like a washing machine. How many of you understand why you would have a processor in a washing machine? Well, it's nice to have the buttons on the front, but the reality is, in motor control, if you can control the motor so that as the motor spins, you add power just at the right time, you can get much more energy efficiency than if you use a very poorly controlled motor control. Things like adding connectivity. We see in 2025, 1 trillion internet-connected devices. Things like your smart meter on your house that talks about your power usage and helps balance power usage across the city. Things like smart appliances I talked about, and other things that maybe add displays and capabilities that you're not used to before. This drive for internet access also drives the need for mobile infrastructure. Of course, we're all used to these giant cell phone towers up on telephone poles across the city, and those are going to continue and expand. But we're also seeing a trend towards more diversity as well, where now we're seeing smaller cells in regional areas and even these very tiny cells on lampposts to help balance out the bandwidth needs across the area. And ARM's high-performance solutions, because with our new high-performance processors, we can deliver very high-performance solutions for this whole marketplace. We're working to enable a more diverse, low-power ecosystem in all of these kinds of areas. So that gives you a brief overview of some of the trends we're seeing across mobile, consumer devices, and infrastructure. And so let's talk next about how do we achieve these designs reliably in silicon. And I think there's 3 things that is necessary to achieve these designs reliably. First is a full, rich IP solution. To achieve these designs, it's very complicated, lots of different blocks you need to have, and given that it's a $6 million tape-out cost at leading-edge nodes, you'd really like to make sure your IP is proven and reliable. Second, given the design complexity, and the reason many of us are here at the show is the EDA support is crucial. We need to make sure that the methodologies at these advanced nodes are ready and proven so we can get to market quickly. And finally, I think early collaboration and early joint work between EDA, IP, the foundries, and semiconductor companies is critical, and I'll talk to you about some of the things we're doing in those areas. So first, let's talk about the IP platform. Now, ARM, if you go to our booth, I'd encourage you to come by. One of the things we're talking about today is that we believe a full solution is needed from bottom to top. So ARM is working, for example, on the software side. We provide a lot of infrastructure for software, tools, and infrastructure, and then have a very rich software ecosystem through our ARM connected community. And that community has partners who do things like tools, drivers, middleware, operating systems, and we aggressively support that ecosystem. Of course, ARM is well known for our energy efficient processors, and I'll talk more about that in a moment. But we also have a very strong solution in graphics as well. Our Mali graphics solution is a strong mobile graphics support, and actually it's gaining very good traction in, for example, the smart TV space, where we have very strong penetration in mobile graphics. Also, to connect these kinds of high-performance cores together, you need a scalable and coherent system IP solution. This is interconnect and other kinds of support for virtualization, and I'll show you more about that in a moment, because those are critical as the systems are getting more and more complicated. And finally, you have to realize all this in silicon. And so ARM is developing optimized physical IP, especially IP that specifically targets ARM cores, because the needs of getting to 1.5, 2 gigahertz cores is very complicated, and you can't just use a generic solution to achieve that. So first, let's show you a little bit about ARM's processor roadmap. This is a roadmap just looking at the mobile device side. If you go back a few years into 2009, 2010, we had very impressive apps processor-based cores, but it tended to be fairly homogeneous. There was a relatively small diversity of these cores. Fast forward to today, and what you're seeing is a much broader diversity across different markets. At the low end of the market, for the mass market value segments, we offer Cortex-A5, which is a very energy efficient and also very cost efficient core that nonetheless gives all the performance you need for a great smartphone. As you continue up into the mainstream smartphone space, the Cortex-A9 core, which is the leading processor shipping in volume today, is great for about the normal mainstream segment in a one-core configuration. And if you take it up higher into a multi-core configuration, 2 or 4 cores, you're already seeing applications in the marketplace today that have multi-core configurations with Cortex-A9. And we're continuing to see that spread out as now companies have tablet-based apps processors that have a higher power threshold than what they put in their mobile device because the tablet can dissipate more power. Coming up later this year and the beginning of next year, you'll see the first application processors based on our Cortex-A15 flagship product. And following that, you're also going to see a combination of Cortex-A15 and Cortex-A7, which I'll talk about next. All told, this is a significant increase in performance compared to ARM11 in 2008, up to 18 times higher performance than ARM11. And these are going to achieve market penetrations in the billion units a year in about a year or so, a billion units a year in these markets. So I talked about right-size computing, and so let me tell you what we mean by that. In the past, there was one main processor that did all the work. Did the processing, it did the background processing, even did the graphics a couple years ago. But now we're realizing that it doesn't make sense to have one size that fits all. Our Cortex-A15 processor, which is a very high-performance processor, is focused on maximum performance and peak performance. It's the thing that's going to make sure your web page renders fast, your mobile game looks great, and you're getting great responsiveness in general. But when you're just reading your email or listening to music or even your phone's in your pocket, you really don't need that kind of performance. So instead we have the Cortex-A7, and what's unique about the Cortex-A7 is not that it's different, because the A15 is a complex, multi-issue, out-of-order processor that's very much competitive with the kinds of processors in your laptop today. The Cortex-A7 is a much simpler, much more streamlined, energy-efficient, mostly single-issue, limited dual-issue processor that's focused on energy efficiency and cost efficiency. But what's interesting is they're fully architectural compatible. So what happens is the same software can run on both of those cores, in fact can switch back and forth between both of those cores in a matter of microseconds. And that allows you to develop a cluster of processors that work together in a cool way. So here you have an example of how a big. LITTLE configuration might work. Here's a 2-core Cortex-A15 configuration with its L2 cache, and a 2-core Cortex-A7 configuration with its L2 cache. But what's cool about this is that it's connected by, first, a coherent interface and virtualization support that I'll talk to you more about in a moment. And it allows the workload to move back and forth between these cores in a matter of a couple of microseconds. So when the application is running full on, it turns on the high performance core. When it's idle or when it uses less power, it goes to the more energy efficient core. This is sort of like having a Prius with a Ferrari engine underneath the hood. When you press down the gas, it goes really great, incredible performance. But when you let off the gas, you get back to the Prius gas mileage that everyone loves. And having that in one configuration is new and really unique to ARM. It's what we call right-size computing. Now, I mentioned the coherent interconnect. One of the important things in having this multi-processor configuration is they have to be coherent and they have to work together. So what ARM develops and offers as well is system IP that connects it together. It starts with things like a cache coherent interconnect, or CCI 400, that uses our AMBA ACE specification for coherency. He continues also with virtualization support, things like our interrupt controller, or GIC, that's the global interrupt controller, and also memory management support, because both of those need to understand that the application is going to move across between these different processors. We also need a high-performance path to memory, and so ARM both develops our own memory PHY and controller designs and also partners with others. And we also have interconnect fabric for the relatively slower performance parts of the system as well. And all of this together is needed to make an impressive system that works together across this diverse set of hardware capabilities. But once you have all this, you still need to realize it in silicon, and that's where physical IP comes in. So ARM develops physical IP and is the leading provider of physical IP spanning many foundries and many process nodes with over 80 different platforms available today. But what we're doing now is focusing a lot on what we call synergy products and making sure that we're developing IP that specifically optimizes for the implementation of ARM cores and ARM-based SoCs. And one of those products is called a POP, or Processor Optimization Pack. A POP has three important things that work together to help SoC designers get their chips to market quickly and reliably. First, it begins with artisan physical IP that is specifically designed for a particular core and a particular process node. So for example, TSMC 28 nanometer on Cortex A15. That's a specific processor optimization pack set of IP. But then what we do is take that IP and implement the core in our own labs and figure out exactly what we can achieve, and we provide a detailed benchmarking report for what you can accomplish. And finally, we provide a user guide that describes exactly how we got there. So you, as a designer, can then incorporate that same learning in your design to get to market quickly and reliably. These processor optimization packs are available today on a broad range of cores, A5, A7, A9, and A15, on process nodes spanning 40 nanometer, 32 nanometer, and 28 nanometer. And that's just the beginning. There's going to be a lot of new exciting news this year about continued expansion of the POP product line into new cores, new technologies, and new processes. And the POPs really allow you to get fantastic time to market and power optimization. So this just gives you an example of one customer engagement working on POPs. And what they did was they had set a target. This is all in percentages. This is 100% of their specific target. And in a matter of weeks, they were able to achieve their frequency target using the POP, which is great because this is a company that was new to ARM cores, very capable designer, but new to ARM cores. So they were able to achieve this design very rapidly using the POP. And then they realized, well, actually, we achieved our design ahead of schedule. We can save power now. So actually what they did was went away from an LVT-only methodology and now putting in a lot of RVT. They were able to drop the power and yet still achieve their frequency goals in a very fast time to market. And we've since seen customers achieve the same kind of result even faster using the processor optimization pack. And given that $6 million leap of faith that we talked about at the beginning, you really want to have predictable results. And so what the POP does is gives you confidence that you can achieve these results quickly and reliably. So I talked next, the second thing we need to do is have great work with EDA and great collaboration. And so one of the things, this is a case study of one POP customer, just as an example. Panasonic, which is a very well-known electronics company, adopted the POP to use for their TV chipset called Unifier. It was in TSMC 40LP, and with this product, they were able to get to 1.4 gigahertz, an incredible number on 40LP with high confidence. And this is a quote with them endorsing it, talking about how it really helped that not only did we have great time to market, but also great EDA support. Another thing we've done is we've collaborated extensively. So last year, we did a lot of collaboration on advanced technologies. Here's an example with TSMC, joint with TSMC and Cadence, where we developed a very advanced A15 test chip tape out on TSMC 20 nanometer technology. The point here is to grease the skids to make sure that we've checked out all of the issues so that by the time you get to your design at this advanced technology, at this advanced processor, everything has been proven and tested. And that's one wonderful kind of proof point. And using the advanced process technology from TSMC, the advanced physical IP and cores from ARM, and the tool chain methodology and tools from Cadence, it ended up with a very successful result, and we're very proud of that result. Similarly, Global Foundries had a similar engagement where on A9 at 28 nanometer, they developed a test chip last year using a dual-core A9 based on a synopsis flow, and they've taken this chip, taped it out in 28, and then also taped out a derivative of this chip in 20 nanometer as well. So this is two different processors, two different processes, two different foundries, two different tool chains, all of which is trying to reduce risk and improve the results for our customers. So in summary, we talked about trends. You know, what are the trends for the next wave of devices? We think they're going to be very connected, intimately linked to e-commerce, driving very strong user experiences, especially highly graphical visual experiences, where energy efficiency is important in everything we do. We always think about energy efficiency in mobile, but the reality is energy efficiency in infrastructure is important for better density. Energy efficiency in wired base stations is important. All of that matters. And we think we can achieve this by driving both a proven IP solution, working closely with EDA partners, and finally, by doing early collaborative work to assure that by the time you get your design in these cases, the hard work has been proven out. Thanks very much. I appreciate your attention.